Again, welcome to lecture number 7. Again, this is Mathematics 200 Business Calculus. In this lecture, we are going to review all the rules that we cover in derivatives. In short, we are going to review all the derivative formulas. So here we are going to solve different types of problems using either the product, quotient, sum, differences, power rule, chain rule, almost all the rules that we cover. So lecture number 7 is using derivative formulas in our textbook, chapter 9.7. So our main objective is to use the derivative formulas separately and in combination with each other. Sometimes we may have a question that we may need to use more than one rule. For example, I may have a question that I may use chain rule with product or with power rule or with a quotient, etc. So let's see our first example here. And this question says we have used the power rule to find the derivative of the functions like this. So here we have y equal to x cubed minus 3x squared plus x plus 1 raised to the power fifth. So if I'm going to use the power rule for this, I'm going to get 5 times x cubed minus 3x squared plus x plus 1 raised to the power 5 minus 1. So that will be raised to the power 4. But remember here, I have to use a chain rule. Why? Because we can also find the derivative in an equation. So here we're going to use the chain rule. But we have not found the derivative of a function like y equal to x squared plus 1, product of x cubed plus x plus 1 raised to the power fifth. So here also we are going to use the chain rule. So first, you can see that we can use the power rule. Same as the first question, we can use the power rule. But later on, we have to use a chain rule. But here, we have a product. So which means we use the chain rule 5 times all the items here, 5 times the 2 terms here to the power 4. Then we use the product rule for the 2 terms, which will be a derivative of x squared plus 1 times x cubed plus s plus 1 plus the derivative of x cubed plus s plus 1 times s squared plus 1. So kind of using 2 rules here. We are using the chain rule in terms of product. Here we are using the chain rule in terms of sum and difference. Here we have x cubed minus, so difference plus and plus. So we're going to see how to solve this problem. And so this is the first example we're going to solve. We have the equation of a form y equal to u to the power fifth. What we're trying to do is that in this question, I can represent x cubed minus 3x squared plus s plus 1 as u. So we're going to have y equal to u to the power fifth. Then I'll get 5 u raised to the power 4 times u derivative. So you find the derivative of this. The same concept here. So here we say that, okay, we have the equation will represent u equal to s squared plus 1, s cubed plus s plus 1. And that is the second example. Let's go back. So here also, if I'm going to solve this, I will use the chain rule. And I'll say all the 2 terms here is u. So it will be u 5 times u to the power 4, which is 5 minus 1, 4. Then times u derivative. So I have to use the product rule to find the derivative of this. So let's see how this problem is solved. Let's follow step by step here. So here they say the equation is of the form y equal to u to the power 5. The reason why, because the 2 terms are raised to the power 5. So here we say u equal to s squared plus 1 times s cubed plus s plus 1. This means that the product rule should be used to find the du dx. So if this is my u, I'll use the product rule to find the u dx. So then the y dx will give me using the power rule. So it will give me 5 times u to the power 4, and u is s squared plus 1, s cubed plus 1 plus, s cubed plus s plus 1. So we can see here the u ds is 5 u to the power 4 times the derivative of u, so it's the u dx. So now we write down the 5. Remember, u is the same as s squared plus 1, s cubed plus x plus 1. So we substitute u with s squared plus 1 times s cubed plus s plus 1 raised to the power 4. Now we have to find the derivative of u, which is the u dx. So this is a product rule. So we can say s squared plus 1 times derivative of s cubed plus s plus 1, which will be 3s squared plus 1. And that's what we have here. S squared plus 1, 3s squared plus 1. Now we have to find the derivative of s squared plus 1, which will give us 2x. Then we multiply by s cubed plus s plus 1. And that's what we get here, plus s cubed plus s plus 1 times 2x. So we already covered the product rule. So if I have a question like this, we will say the product is a product because we have s squared plus 1 times s cubed plus s plus 1. So I'll find the derivative of s squared plus 1, which will give me 2x. Then I'll multiply it by s cubed plus s plus 1. Then plus derivative of s cubed plus s plus 1, which will give me 3s squared plus 1, multiplied by s squared plus 1. And that's what we have here. So this is a chain rule concept. Now, the only thing left now, we have to simplify this equation. So we write down the same term here. We open the parentheses here and combine the like terms. We get 5s to the power 4 plus 6s squared plus 2s plus 1. Then we can also open the parentheses given to us here. And we can also combine the two terms here. So here we have 25s to the power 4 plus 30s squared plus 10s plus 5. Then s squared plus 1, s cubed plus s plus 1. So again, why? I don't want to use this 5 to multiply the terms here because the terms here is raised to the power 4. But here, the terms here is raised to the power 1. So this is basic algebra. Multiply 5 by everything here. That's what we have here. 5 times 5 is 25. 5 times 6 is 30. 5 times 2 is 10. 5 times 1 is 5. Then we multiply by the 10 here again, raised to the power 4. I don't want to, here we can leave the answer as what we have here. Because if I say I want to simplify this raised to the power 4, it will be a very long process. So we can leave the answer as this. Now the next, we have a different type of problems involving the power rule and also the product rule. It's finding the derivative of this. So let me start from beginning again, make sure we understand the concept. So you can see that the first example, actually we didn't solve this problem, but this first problem here, just by looking at this question, I know I have to use the power rule. Why? Because it's raised to the power 5. So it will give me 5 times s cubed minus 3s squared plus s plus 1 raised to the power 5 minus 1, which is the power rule. So it will be raised to the power 4. But chain rule, we have to find the derivative of the term. So the final answer will be 5 times s cubed minus 3s squared plus s plus 1 raised to the power 4 times the derivative of the term here, which will give us 3s squared minus 6s plus 1. So that will be our final answer. Again, the answer will be 5 times s cubed minus 3s squared plus s plus 1 times 3s squared minus 6x plus 1. The second question, we solve it. We say, okay, let's the term here represent u. So we say y equal to u to the power 5th. And I'm going to use again chain rule and the power rule. Here, the term here is a product, so we're going to use the product for the chain rule. So we get 5 times u raised to the power 4 times derivative of u. We are assuming all the terms here is u. And that's what we have here. So y equal to u to the power fifth. Why? Because u equal to s squared plus 1 times s cubed plus x plus 1. So here, derivative of y will give me 5u to the power 4 times du dx. As we said earlier, again, this is a product. So I'll find the derivative of s squared plus 1. I'll multiply by s cubed plus s plus 1 plus derivative of s cubed plus s plus 1 multiplied by s squared plus 1. And that's what we have here with the power rule also. Then we multiply the 5 by all the terms here. Why? Because the exponent here is 1, so I can do that. Here the exponent is 4, so I have to multiply the terms here 4 times before I can use the 5 to multiply it. So I use the 5 to multiply the term with 1 exponent. So this will be our final solution. As I said earlier, to expand this to be very long answer, this is raised to the power 4. That means we have to multiply the 2 terms here. And after that, we multiply the solution 4 times. So there's no need. So let's look at another example here. Here we have y equal to s squared plus 1 raised to the power fifth, s cubed plus s plus 1. So here you can see that we have a power rule, and at the same time we also have what? A product rule. And also, of course, the sum rule, but sum rule is very direct. So what we're going to concern here is that we have a power rule, and also we have a product rule. So here we say we may think of y as the product of two functions, but one of which is a power. Thus, the fundamental formula we should use is the product rule first. Product rule. So here we said, okay, let's assume u at x equal to s squared plus 1 to the power fifth. And let's say v at s equal to s cubed plus s plus 1. So we're going to get uv times, so u at x times v at x. So which means product rule, derivative of u at x times v at s plus derivative of v at x times u at x. So let's go to the next slide. So here we say, okay, dy dx will give us again u at s times derivative of v plus v at s times derivative of u. So I know u at x is given to us. Derivative of v will give me 3s squared plus 1. Then v at s is s cubed plus s plus 1. But remember, u is a power, s squared plus 1 to the power fifth. So this is why I say we use the power rule. So we can see we get 5 s squared plus 1 to the power 4. Then we find the chain rule of s squared plus 1, which will be multiplied by 2x. So we should pay very attention here. See, if I have s cubed plus s plus 1, the derivative of it will be 3s squared plus 1, which we have here 3s squared plus 1. But when I have s squared plus 1 to the power 5, I'll use the power rule first, which is 5 s squared plus 1 raised to the power 4. But we can find the chain rule. S squared plus 1 will give me 2s, so multiply by 2x. So this will be the derivative 5s squared plus 1 to the power 4 times 2x is the derivative of s squared plus 1 raised to the power 5 using the chain rule. And then here they say we should note that the power rule was used to find the derivative of u, since what? U at x equal to s squared plus 1 to the power fifth. So again, this will be our final answer. I don't want to open s squared plus 1 5 times. That would be too long. Maybe what we can do is that we can multiply 5 and 2s to give us 10x. Then if you like, we can multiply 10x by this term here. But we don't want to open the exponent 4 and 5. Otherwise, we have to multiply 4. The term have to multiply by itself 4 times and also 5 times. That will be too long. And actually, that's what we did here. So we multiplied 5 by 2x. So that give me 10x. Then I use the 10x to multiply s cubed plus s plus 1, which gives us this. But again, we are not going to open parentheses 4, the power 4. Okay, so this is another question again. They say we should find the derivative of f at x. If f at x equal to s minus 1 all squared divided by s4 plus 3 to the power cube. So here also we can see that we have a powers in the two terms. But at the same time, we have also what a quotient. So we are going to use our primary rule here will be the quotient rule. But in the process of finding the derivative of, let's say the top is u and the down is v, the process of finding the derivative of u or s minus 1 squared, we are going to use the power rule. But the primary rule should be quotient because this is a quotient term. So let's see how it works. So we are going to use the quotient as I said earlier. So let's assume that u is x minus 1, v at x is s to the power 4 plus 3. So in this case, I have to find the derivative at the top times the down minus derivative at the down times the top, all divided by the square of the down. And that's the formula here. V at x times u derivative at x minus u at x times v derivative at x, all divided by v at s squared. So here we should pay attention to the power also. So you can see that the first, we have s4 plus s to the power 4 plus 3 raised to the power 3 right here. Then we have to find the derivative at the top first. So that will give me 2x minus 1. Luckily, the chain rule here, derivative of x will be 1. So we just leave it. Actually, we write it down 1. But 1 times any term is the same term. So we get 2x minus 1 times 1 minus the derivative at the down. The derivative at the down will give me 3s4 plus 3 raised to the power 2. And that's what we have here, 3s to the power 4 plus 3 raised to the power 2. But remember, this is a chain rule. Here, the chain rule will get only s minus 1. The derivative of s minus 1 is 1. But the derivative of s to the power 4 plus 3 will give me 4s cubed. So that's why we have 4s cubed. Then we multiply that with the numerator, s minus 1 all squared. And that's what we have here. So it's like the derivative at the top times the down minus the derivative at the down times the top, or the square of the down. So we have s to the power 4 plus 3 cubed all square again. So as we said earlier, the primary rule we're using here is quotient. Why? Because the term is in quotient. In the process of, again, finding the derivative, we have power. So we're going to surely use the power rule when we find the derivative. But the formula we have to use there. Same as the previous example, the term was product. So we have to use the product rule as our primary. But in the process, some of the term is raised to a power. So we have to use the power rule. So here we can simplify and we say we can leave our final answer as it is. If you want to factorize again, simplify, that's fine. Okay, so let's see the next example, which is, this example is about revenue. Here they say suppose that the weekly revenue function for a product is given by the following. Again, looking at the function, it's a quotient. We have 36 million x divided by 2x plus 500 all square, where r at x will be our revenues in dollars for the sale of x units. So S is the number of products as units. So here they say find the marginal revenue function. The marginal revenue function means we have to find the derivative of the function. Then find the marginal revenue when 50 units are sold. So after we find the marginal revenue function, we substitute x for 50 and we will know the actual marginal revenue. So again, this is quotient. So let's keep going now. Since this is a quotient, what we did, I find the derivative of the top, which is 36 million x. The derivative of 36 million x is 36 million times the down. The down is 2x plus 500 all square minus the top is 36 million x times the derivative of the denominator, the down. So the down we have 2x plus 500 squared. So it will be 2x plus 500. Remember, this is the power rule. Raise to the power 2. So 2 will be in the front. Then 2 minus 1 will be 1. Then the derivative, chain rule, the derivative of 2x plus 500 will give me 2. So we are using the chain rule here again. All divided by the square of the denominator, which was 2x plus 500 square. So square will give me 4. Raised to the power 4. So from here, we can simplify, maybe multiply 2 by 4. Then we multiply 4 by 2x plus 500. Then later we multiply it by 36 million x. Then if we like, we can square 2x plus 500. Then we multiply 36 million with it. And that's what we did here. So we get 4x plus 500 and then minus 4x based on this value. And we still simplify the inside. Normally, I'm not going through how to simplify this equation. This is a calculus class. So this is a college algebra. Basically, here means I can multiply 2x by every term here, 500 by every term. Then I'll combine the like term. We're going to have a like term of s squared and then constant value x. Then we combine the terms. So that's what, for example, here we get 4s squared. Then we get 1000x. Then we get another 1000x. Then we get another minus 2000x. So we can see that the x's will cancel. 2000x minus 2000x will cancel. So we get 500 minus 2x. That's why we got this. Then we have 2x plus 500 to the power 4. So here we can stop. Then B, remember they said we should find the marginal revenue when the total units sold is 50. So we substitute X with 50, then we solve the actual revenue amount. And that's what we did here. Revenue at 50. So anyway, we see X, we put 50 there. Let's go back. We have 2X. So it will be 2 times 50. So this will give us 100 here, and this will also give us 100 here. So we have 100 and 100 because it's 2x and 2x. Then we can simplify this. We get 436 million. Here we get 600 to the power 3. We need a calculator here to do this. And the final answer will be 66.67. Again, the main thing I want us to know here is that the question said we should find the marginal revenue. So anytime we are looking for a marginal revenue function, it means that find the derivative of the function. That's the main thing. So the marginal revenue is $66.67 when 50 units are sold. That is, the predicted revenue for the sale of the 51st unit will be approximately 66.67. Here we say it may be helpful to review the formulas needed to find the derivative of various types of functions. I will post another video whereby I'm going to solve somewhere between 10 to 20 questions using different formulas and also rules of the derivative. At the moment, we finish with all the derivative formulas. So now we have to, this calculus class need a lot of practice, especially solving derivative problems you are using formulas. Basically, we're going to use formulas rules. So if it's very new to us, then we need to practice a lot to practice. So we're going to solve more problems after the end of chapter 9. So example is given here, and this is a table 9.5 present example of different types of function in the formulas needed to find their derivatives. So if I have f at s equal to 14, of course, this is a constant rule. Remember, constant rule in derivative, any constant value, the answer is 0. So derivative of 1 million is 0. Derivative of 1, 2, 3, any value is 0. So here we say f at s is equal to c, constant. Therefore, derivative of f at s is 0. Now we have y equal to s to the power 4. Okay, that's a power rule because we have 4. So we know x to the power n means n times x raised to the power n minus 1. This is our rule, power rule. So the answer will be 4s cubed because the power is 4. So 4 will multiply x. Then the exponent will be 4 minus 1 as n minus 1. The next question also is the same thing. We have power rule and constant. But here we call this 5 as our coefficient. We don't say that, okay, the derivative of 5 is 0, then the derivative of s cubed is 3s squared. No. Anytime we have a value in front of a variable and we are finding the derivative, we leave the value. We don't touch the value. So you can see here, this is c, the constant value c, we leave it. Then we find the derivative of the variable. So actually here, the answer will be 5 times 3s squared, which will give me 15s squared. The answer will be 15x squared. So the derivative of 5s cubed is 3 times 5, 15x, 3 minus 1, 2, so 15x squared. This is our sum rule, 3x squared plus 4x. So the derivative will give us 6x plus 4. We have to find the derivative of each term. Now the product rule, we have to find the derivative of s squared minus 2, then we multiply it by s plus 4. Plus the derivative of s plus 4 we multiply by s squared minus 2. So that's why when you look at the rule here, we say u at x times v derivative at x plus v at x times u derivative at x. Then the quotient, we said s cubed, we find the derivative at the top, multiply by the down. So s cubed will be 3s squared times s squared plus 1 minus the derivative at the down. S squared plus 1 will give me 2x multiplied by s cubed, all divided by s squared plus 1 all squared. And that's the rule here. So we get v at x is the denominator. So v at x times the numerator u derivative at x minus the numerator u derivative at x times the derivative of the denominator v derivative at x, all divided by the denominator square. Okay, so the next one we have s cubed minus 4s to the power 10. If I have this question, we need to use the chain rule. So first I'll use the power rule, that this will be 10 times s cubed minus 4x to the power 9. Now times the derivative of s cubed minus 4x, which will be 3s squared minus 4. And that's what they write here. So we can see that we have n, which is our power. The u is our 10, s cubed minus 4x to the power n minus 1. Then multiply by the derivative of u. So that's why the answer will be 10 times s cubed minus 4s to the power 9 times the derivative of s cubed minus 4x, which is 3s squared minus 4. The next question here also, we have the quotient and power. So this means we also have to use the power rule first as our primary rule. Then the chain rule, we have to use the quotient. So the answer here will be 3 times s minus 1 divided by s squared plus 3 to the power 3 minus 1, which is 2, times the derivative of s minus 1 over s squared plus 3. So that will give me the derivative of s minus 1 will be 1 times s squared plus 3 minus derivative of s squared plus 3, which will give me 2x times s minus 1, all divided by s squared plus 3 all square. And you can see the formula here. So first they say use the power rule. This we have to use the power. Then the quotient as the chain rule to find the du dx, where u is s minus 1 over s squared plus 3. The next question we have s plus 1 times s cubed plus 1. Okay, so this also is times, so I have to use the product rule. So use the product rule first, then the power rule. The power rule will affect the square root because we know a square root is the same as power to the half, power half. So if I'm solving this question, I'll say, okay, derivative of s plus 1 is 1, so 1 times s cubed plus 1 raised to the power half or square root plus derivative of square root of s cubed plus 1 will be half times s cubed plus 1 raised to the power negative half times s plus 1. That's it. So derivative of the first term times the second term plus derivative of the second term times the first term. Okay, so here also we have s cubed minus 3 to the power 4 s plus 1. We can see the difference between these two. Here, the power affects everything, so we'll use the power rule first before the quotient rule for the chain rule. Here we have the power rule affect only the top. So we are going to use the quotient rule first. Before, if I'm looking for the derivative of the numerator, I'll use the power rule also. So we can see the difference between the two. Again, one more time, hopefully you can see my cursor. In this question here, we have the power raised to everything. So we have to use the power rule first, then the chain rule for the quotient. But here, the power affects only at the numerator. So we have to use the quotient rule first. Then when we are finding the derivative of the numerator, we use the power rule. So here, the answer will be 4 s squared minus 3 to the power 3 times 2x, chain rule, times what? S plus 1 minus derivative of s plus 1 will be 1 times s squared minus 3 raised to the power 4. Everything raised by s plus 1 square. So one more time. Here, the 4 affects only the numerator, so I'm not going to use the power rule begin. I have to use the quotient. Here, the power affects everything, so I have to use the power rule first before the chain rule we use the quotient. Here not. But we know that in quotient, first I have to find the derivative at the top. Then I'll multiply by the down minus derivative at the down, multiply by the top. So derivative at the top will be 4 s squared minus 3 to the power 3 times chain rule. This will give me 2x. Then minus derivative at the down will give me 1 times s squared minus 3 raised to the power 4. Everything divided by s plus 1 square. Okay, so this will be the conclusion of our lectures today. This is lecture 7. We finished with all the derivative formulas, and here we just look at some of the problems or questions that we may have to use more than one rule. Most of all the examples we do, we use only one rule. This time we have to use more than one rule, and we saw some few examples. Also, when the homework assignment is assigned, I'm going to solve some more problems, hopefully by next week. Thank you. Again, this channel is a YouTube channel, so you can comment it. Positive comment is welcome. Negative comment also is highly welcome. And my goal is to improve on the videos. So if you like it, fine. And you don't like it, also raise your comment. so that I can improve it. Also, you can subscribe it. This is a channel, and the channel is my name, Chasebeke. Thank you.